Across Australia, the wheels of industry turn 24 hours a day, 7 days a week. These machines are tough, and the teams of people running them are even tougher. But what happens when these massive machines break down?
That's the fun bit.
Teams of mechanics, engineers, fitters and boilermakers step up to battle against tight deadlines in some of the harshest working environments on the planet.
These are the optimum working conditions.
From deep underground, on the water, on the front line, to high in the sky, they do the vital repair work to keep these heavy metal wonders alive.
Planned out well, it turned out better.
This is Mega Mechanics. This time on Mega Mechanics. At the Kooragang Coal Terminal in Newcastle, New South Wales, the tip of a massive shiploader is getting a 6.5-ton facelift.
It's the very last part of the plant that touches the coal before it enters the ship. It's the last thing we want to go wrong, essentially.
But a new design could mean big problems.
We might have an issue. Hang on. Take him back down.
At the Hastings Deering Complex in Mackay, Queensland, something mega is going down, or up, with two massive cranes helping to bring one gigantic dump truck to life.
There's a few risks, suspended loads, quite a bit of weight to lift.
Tons of metal and loads of pressure. A lot can go wrong. And at the Snowy Hydroelectric Scheme in Guthaga, there's double trouble, with maintenance teams battling to get both of its generator units pumping out power to nearly 40,000 homes. Dodgy brakes and 24 snap links are holding the turbines from getting back up to speed.
That might be a bit of an issue, that brake dust here around the bottom.
All the while, the station's lifeblood is flowing downstream.
This water that you can hear running is lost revenue to the business, it's lost energy into the energy market, so there's all this lost opportunity.
This machine here is 710 ship loader, and as the name suggests, it loads the coal onto the ships. What we're doing is, you see the round section, that's called the spout, and just below that, near the ground, it looks a bit like a bucket. That's called the trimmer flap. So we're basically changing both of those components.
On the banks of the Hunter River in Newcastle, the southern end of the wharf at Kooragang Coal Terminal is a hive of activity, thanks to an important upgrade.
Current ship loaders, the spouts, they can't articulate all the way up. So this project is, we're changing the bottom of the chute, which is called the trimmer flap. We're giving it an extra range of motion to be able to fully fold in underneath itself. And the purpose of that is that when it's approaching the ship or coming away from the ship anywhere over the water, we'll be able to be completely captive any material.
When operating, 10,500 tonnes, or nearly $1 million of coal pour through these spouts every hour, meaning the less chance of spillage, the better.
The new design that we're actually installing is going to help capture any coal that is left in the chute once we finish loading a vessel. So having a chute that's going to actually capture that means that there will be no chance of the coal entering into the harbour. It's also not going to contaminate any of the vessel surfaces and allow for a cleaner wash down to ensure we've got a fresh spoon and chute every time we load a new vessel.
Posing the greatest risk to the upgrade is the new design itself. Any lessons learned with this trial run installation will make the upgrade to the other two shiploaders on this wharf invaluable. 100 metres long and weighing in at 1,450 tonnes, number 710 shiploader is a mechanical behemoth. In comparison, the spout and trimmer flap are relatively small. Despite their size, they are vital components. Standing 7 metres tall, the new spout weighs about 3.5 tonnes. The trimmer flap, an additional 3. The new components will be trucked, then craned onto the wharf. Teams will remove the old components, aided by a crane and cherry pickers. Next, the new spout will be raised to a vertical position, then hoisted via crane and multiple block and tackle devices. Once attached, the new trimmer flap will be lifted into position and bolted in. With a strict 3-day deadline, teams of mechanics will be working in shifts around the clock to get this shiploader upgraded and back in operation.
This is the very last part of the plant that touches the coal before it enters the ship. Yeah, it's the last thing we want to go wrong, essentially.
We call that the squared around. We've basically changed that whole section before. We're walking into this knowing what we're doing, and you just got to take your time, go through the process, because as you see, there's a lot of other work groups here. You've got to make sure you work safely, and we've all got to make sure we've got our own bit of room to work in.
The newly designed Spout can't help but make a grand entrance.
Hang on. I think we're spinning 180 degrees. We're just talking about it now because that'll aid us later on that we don't have to sort of move this again.
Out with the old. The process starts, and so does gauging the hazards.
Just watch it. That might bounce out a little bit, Matty, so just be careful that actuator doesn't clock you. You're in a strike zone.
Best case scenario today is to have all our major lifts completed in the one day and everyone finishes work the way they came to work, with all their fingers and toes and everything in place.
About halfway up the Queensland coast lies the city of Mackay. This seaport is not only famous for sugarcane, but also mining, thanks to its proximity to the Bowen Basin, Australia's single largest coal reserve. A few kilometres south of the city centre, 2 massive cranes are pulling into the Hastings Deering complex, a sure sign something big is about to go down.
Today's job plan is to assemble 4 of the major components to this Cat 794 off-highway truck.
With the assistance of 2 60-tonne cranes, the team will bring the 4 main components of the US-built Cat 794 truck together: the front axle, the chassis, the superstructure, and the rear axle. Starting with the 189-tonne chassis, lifting chains will be attached. Then the cranes will hoist it in unison, moving the chassis into position above the front axle. Once retaining pins are installed, the chassis and front axle will be lowered onto machine stands. Next, the cranes will haul the superstructure into position. When bolted in, the rear axle housing will be craned in and connected. When completed, this $8 million truck will be 15 metres in length and have a 297-tonne payload, powered by 2,610 kilowatts of grunt. That's about 30 times more than the average car. All this has to be done today.
It will be a full day, probably looking at 10 to 11 hours to get from this scenario to half-complete machine. Used out on a mine site to carry coal, dirt, rock, etc. from one place to another. So we've got all the guys here from Middlemount Coal, just coming to see their truck getting assembled as well.
I just wanted to come and celebrate that moment with the team. We've got 5 of these trucks in a fleet on the mine currently running, and we needed a 6th truck to complete that one fleet, and this will be that truck.
With added pressure of the clients looking on, bringing these enormous pieces together will be a mammoth task for this well-trained crew.
I have good confidence in my team. This isn't the first one of these trucks we've put together. Probably up to nearly our 10th truck now. Me personally, I like to see all the big cranes and all the different working groups working together, working well, putting big, large components together. There's a few risks, suspended loads. We've got quite a bit of weight to lift.
When fully assembled, this hefty beast will total about 218 tonnes. No wonder it's a 2-crane job.
This first crane, they're setting up to attach to the front of the chassis. So they're just getting all their slings and attachments ready. They're also just setting the counterweight for the crane. The dogman is whistling to the crane driver to let him know whether to go up, down on the crane. Therefore, he's got eyes always on the load that he's controlling. It's another way of communication.
The first component to take flight is the 189-tonne steel chassis.
The main component of the truck that's got your engine, all your major components within inside the machine. They're prepped at the back now to lift the back. They've just got to prep the front. Once they're connected, both cranes will go up simultaneously and then move forward to come over the front axle. They'll lower onto the front axle and then the boys will come in and put the retaining pins in for the front axle.
That bottom one is pretty much just sitting in there. It'll just a little tap and go, or drop.
The most difficult part to pull off is just communication between everyone.
For safety's sake, only essential crew are permitted in the assembly zone. All others have to keep their distance until required. The chains are taking the strain. This is the moment of truth. 189 tons is about to go airborne.
The water behind us here that you can hear running is used for energy. The power station is driven by two 32 megawatt units, which have been in service now for 70 odd years.
The Snowy Mountains in New South Wales, home to the highest peaks on mainland Australia. In winter, they're a mecca for snow sports. That snow not only fuels fun, but also the energy needs of millions of Australians. Thanks to the Snowy Hydro-Electric Scheme, one of the civil engineering wonders of the world. 16 major dams, 80 k's of tunnels, 145 kilometres of aqueducts, and 9 power stations, one of which is Guthaga. Marty is the maintenance manager for the region, a challenge as big as the surrounding Alps.
This is the original, this is where the whole Snowy Hydro scheme started.
Unexpectedly, the dam is full and water is now spilling over the wall, a spectacular but costly sight to Marty.
There was a report the dam levels were getting high.
It's bad news, as both of Guthaga's units have issues at present.
My team's down there at Guthaga Power Station working safely and tirelessly to try and get the units back up and running, because this water that you can hear running is lost revenue to the business, it's lost energy into the energy market, so there's all this lost opportunity.
Guthaga is a conventional hydroelectric power station situated above ground. To generate electricity, waters in the reservoir behind Guthaga Dam flow through a tunnel, a surge tank, then 2 steel penstocks into the 2 units at the power station. To get the first unit running again, 1 kilo cylindrical metal pins need to be lined up by hand into 24 snap links in the turbine's guide vanes. Guide vanes direct water around the bends in a turbine nice and evenly. Each pin must fit perfectly in order for the entire set to be installed. The station's other unit, which is brand new, is experiencing problems with the turbine's braking system. The team will make a visual inspection inside the turbine, then make coding changes to the operating system. This will hopefully stop the shuddering and avoid any damage to the bearings. The team must get both units running before this evening's energy demand peaks.
Just recently, Unit 1 was replaced because it had reached its end of life and we were having some maintenance issues with it. The whole key to the game is get these units back up and running and generating so that I can stand here and not hear water running in the background.
To get things cranking, Marty gets going.
Today's program is we need to get in and focus on getting the MIV maintenance seal off, get the unit fully restored. The other job that's on today is we have Unit 1, the newly installed unit. We need to go and do our warranty internal inspection. Anything we may have missed.
Martin, it was noted this week that we have a high vibration from the brake shutter on Unit 1, so I'll get Sarah today to have a look on the internal on that.
2 jobs, 2 teams. Working on Unit 2's turbine will be Tom and Matt, installing the snap link pins into the guide vanes.
So which pin, Tom?
Number 23, Matt. This one just down here. Let's give it a test fit and see if it will go through. It's nice through the actual snap link.
Yeah, and the reg ring fits beautiful. I'll just check if we can actually get it in. Nah.
Just watch it. That might bounce out a little bit, Matty, so just be careful that actuator doesn't clock you. You're in a strike zone. That's it. I'm happy for that there. So that's happy, so we can probably take that off now.
At the Kooragang Coal Terminal in Newcastle, it's day one of a 3-day job to replace an all-important tip on a ship loader.
Get this pin out first, this side.
Yep.
And then we'll go to the other side.
Yep.
Removing one trimmer flap will take a franner crane, lots of chains, and a team in a cherry picker.
Basically, you've just got keeper plates that holds the pin in so that it can't actually work its way out. So we just get rid of those keeper plates, then get set up with the rigging gear on the franner here, and we'll see if we can knock these pins out. There's not much room to manoeuvre up here in regards to the basket and the trimmer flap and the machine itself. So the more eyes watching, the better, because we can't see everywhere at once. Hopefully the pins will play the game and come out nice and easy.
Yeah, it's clear tight through there, so yeah, just keep getting a little pad, we can find that nice sweet spot. Lose a little bit of weight.
Success. Now for the other side.
Loved your work. Right, let's get out of here, eh? Don't normally come out that easy, but we had a bit of a win.
3 tons down, 3.5 to go.
Yeah, we're just setting up with these chain blocks, ready to take some bolts out and lower it down.
Wayne and the team have only an hour to get this done before the end of their shift, in preparation for the afternoon crew so they can lower the spout.
So there's 96 M16 bolts. I've got to break away from there. Precision face, machine face, so just taking a bit of care with it. Obviously they don't want to damage the bearing, so it's actually quite a slow process to slowly break it away. I'm pretty confident. We've got 8 excellent tradesmen on the job, so I feel that they're up to the task.
It's a long drop from the baskets to the wharf below, even further down into the harbour. Working at heights is one issue. Safely securing and spreading the load is another.
At the moment, they've got 4 3-ton chain blocks up to it. Obviously, they need the 4 blocks to safely manage that weight to bring it down into the cradle.
I've got every second bolt out. Don't know what the other guys are doing.
The race is now on to get the last of the bolts out.
What we've got here is a Caterpillar 794 electric drive truck used out on a mine site.
At the Hastings Steering Assembly Pad in Mackay, 2 massive cranes are working in tandem, helping to bring this monster of a truck together.
That's your main component of the truck. That's got your engine.
After careful prep, the first piece of this enormous mechanical puzzle has lifted off. It's a low, slow flight for the truck's chassis, the riggers expertly guiding the crane operators above.
There's pins each side, and everything's got to line up perfectly if you get your pins in, make it all work, basically.
Gradually, the chassis is eased down, then dangles ominously in place, while teams working on either side connect it to the second major component, the front axle.
This is your steering assembly for the truck.
Wrangling 189 tons into position is a challenge. The pins aren't petite either, each one weighing about 80 kilos.
4140 high tensile steel. Getting ready for the rear axle to be fitted to the main frame. We're basically cleaning this pin, taking all the rust proofing off it after transport.
Once these first 4 pins are aligned, the remaining pins for the front axle
should be all squared up. It should go in a lot easier. Basically, you've got 4 separate lateral links with 4 separate pins, as well as the chassis, and then the front axles are sitting on the ground, so it's just aligning everything up. The pins that go into the pin bores, they're interference fit, so there's minimal clearances. So this is probably the first little hurdle.
2 teams racing to drive these stubborn pins into their new home.
The crane operator is sitting there just holding position, waiting for the dogman, which way he needs to operate the crane, either up, down, left, right, so forth.
There are 6 pins on each side, a total of 12 to install, and so far only 8 are in. With the clock ticking and tons of metal hanging above them, the pressure's on for the teams to slide the last few into place.
Let's give it a test fit and see if it will go through. It's nice through the actual snap link.
And the reg ring fits beautiful. I'll just check if we can actually get it in. Nah.
In the snowy mountains, the maintenance team at Guthaga Power Station are under the pump, getting both of its generators back on board. In the machine hall, one of 24 pins is holding up progress with Unit 2's turbine. Matt's on the case.
Got a bit of damage coming out, so just going to lineage what looks like a slight raise in the machining. Just give it a bit of a polish up. Job done, hopefully. Yeah, it is definitely a bit out. There's no way that's going in there.
So we're going to have to adjust the reg ring for the snap links to line up correctly.
Yeah.
When we pulled them out, we adjusted the reg ring to take the pressure off the guide vanes. So for the rest of the 23 to go in, we're going to have to adjust the reg ring.
To get this done, the guys have to split up.
So I'm just using the hand wheel here to adjust our reg ring. We need to do this to open it up to approximately 1.5%. That's where we left it on isolation. It's generally in normal operation run by a hydraulic system, but for small adjustments we can do it by hand.
Give it a bit of a move, Will. I'll tell you when to stop. Yeah, a bit more. Bit more. Okay, I'll try it there. Hang on. Straight in. That's perfect.
1 down, 23 more to reinstall. In another section of the power station, the other team, mechanical engineers Adam and Sarah, are dealing with the brake shutter on Unit 1. Together, these two have to get it back up to speed fast.
Brake shutter would indicate that the brakes are potentially bouncing on the rotor rim, which could transfer vibration and potentially cause damage to the bearings or cause the brakes to fail catastrophically.
Let's reduce this brake application speed from 25 down 15% and see how that goes for us.
Well, the brakes are part of the new generator and we've got to be careful what we do because the machine's under warranty.
Let's have a look inside this unit and see if there's anything obvious with this brake issue.
It's a 110-tonne rotor that's spinning at 428 RPM and we need to stop that.
A lot of force.
It is a lot of force, a lot of energy there, and we need to make sure that those brakes are working 100%.
That might be a bit of an issue, that brake dust here around the bottom.
That lower chute assembly is only about 3.5 tonnes, so obviously they need the 4 blocks to safely manage that weight.
On the Hunter River north of Newcastle, the Spout on a massive shiploader is about to be offloaded onto the Kooragang Coal Terminal wharf.
They would have preloaded those chains up, so there won't be a drop. It used to be a gradual lower as each of the 4 corners take the weight. They can safely remove it down the way to the cradle.
We've got every second rolled out up there, so we're just going to probably pass that over to the afternoon shift now, I think. Maybe they can lower it in the cradle and we can continue on tomorrow.
It's day 2 of this difficult 3-day job. Wayne and the crew are back on site. Yesterday afternoon, the second shift successfully lowered the spout. Getting it horizontal is the day crew's first task.
The weight of this spout's probably about 3.6 tonne. Then you're going to throw on the cradle. I think we're sort of looking around 4 tonne, so it's a substantial sort of a load there. It really doesn't matter what sort of load, you just got to make sure you rig it right. It's all balanced.
Through whistles and hand signals, the dogman guides the frantic crane operator.
Whoa! The chain's on the motor. Just might want to have a look at this. Get him to hold up there, Dodsy. The chain is fouling on the electric motor for the linear actuator, so it's good. We got, 4 sets of eyes, 5 sets of eyes all looking and watching each corner. We all want to get it done quick, but it can turn ugly if you don't take your time.
The old spout is down. Now it's time to lift the new spout into position. But just as they start, there's a problem.
Have a look at the lights.
Yeah, right. Oh, we've just got this issue here with this main light facing down on the chute. Looks like it's going to have to be relocated to be able to get the crane hook close enough to lift the trimmer flap.
The positioning of the lights is going to make this job harder. They need to troubleshoot this now.
We might be able to disconnect the mount and just move it to the sides.
Definitely for the future shoots on the other 2 machines, we'll design around it next time.
The obstacles for the team are starting to mount. Plus, the wind is picking up. The cherry picker teams need to get the chains attached as soon as possible. Their game plan has to be perfect.
So here's how we'll play it, I reckon. We've got 1 free lug, so you guys hook up first to that. Once you've done that one, we'll do the diagonal and hook up with Darren helping us out, dropping chain blocks and stuff. Then we'll just do the other 2.
Time to put the plan into action.
So once all the pins are in for the front axle, then the whole chassis will get lifted up.
In Mackay, a monster mining truck is being brought to life by the Hastings Deering crew.
My team here on the EA pad, equipment assembly pad, majority these are the trucks. If we were to build any trucks up here in Mackay, these are the trucks we build, 794, 796 Cat off-highway truck.
The first 2 pieces, the 189-tonne chassis and the bulky front axle, are almost joined. But the last few connector pins are being stubborn. Keeping the massive hulk suspended are a pair of 60-tonne cranes.
Just having a little bit of trouble with the other side lower pin. She's in now. So they're just looking to install the pin of the front suspension strut to the front axle assembly now. This is your front, sort of like a shock absorber, which you'd have on the car. This is like your front shock absorber on this truck.
A block and tackle inches the sections closer. Then the cranes pitch in, lowering the chassis to line up the holes.
The crane operator, they've lowered the chassis onto the front axle now, lowered it a lot lower than what it was previously, just to get these pins in for the front suspension. Well, that's like a lever bar, podgy bar, they call them as well. Keeps your fingers well away from pinch points.
Finally, all the pins are in. The next step in the process is just as intricate.
We'll be looking to bringing the whole chassis slash front axle up to a height where we can store the machine stands underneath the machine, lower it down onto the stands and then unhook the cranes.
Until then, the cranes will be earning their keep, now supporting the combined weight of the chassis and front axle, over 205 tonnes.
We'll be using a forklift, so once again, forklift, plant machinery interactions, communication again. Amongst this whole thing, communication's probably our biggest factor.
how well the crew work together will make or break a safe landing for this $8 million hunk of metal.
We've got some brake issues. Got a shutter reported on Unit 1.
At Guthaga Power Station in the Snowies, maintenance teams have 2 generators to get online before the evening peak. Tens of thousands of homes relying on the 68 megawatts of electrical energy it pumps out to the grid. It's a tight fit to inspect the brakes.
We've got a bit of brake dust here around the bottom. That might be a bit of an issue. That's an indication that something's going wrong.
Considering we have brake dust extraction system on this unit, you wouldn't expect to see that.
We should do some extra checks on tightness of the brakes and fixings.
Notice the brake ring got a few vibration marks on it that look abnormal.
Yeah, it looks like there's been a bit of chattering of the brakes.
This is a brand new generator, so it's not a good sign.
Code changes to reduce that brake application speed might be useful in this application.
We should start looking at what the hydraulic operating pressure is. Maybe that's a bit high.
While they troubleshoot the brakes, work on the station's other unit has amped up. Delays have caused only 1 of 2 dozen snap links to be reinstalled. All hands are on deck to ensure they're in. The evening deadline is looming.
That link there that goes in there.
You just drop that in.
Which way you want to go, Matt?
Go open.
Open? All right, moving.
Yeah, it's not much.
How's that?
It's still not. Right, that's good there, Tom.
The team's working flat out. Time's flying by, as fast as the water's gushing down the spillway outside.
We're losing money, we're losing revenue, we need that energy and we need it now.
We're going to have to move pretty efficiently on this. We've got a test run scheduled in for a bit later on this afternoon, and it's important that we hit these targets.
It's hard to line it up, that line up with that thing at the same time, isn't it?
This is the way they come in.
There we go.
That's what's been a good chat. That one's home.
Back at Unit 1, Adam and Sarah are about to put their theories to the test.
We've got to be careful what we do. We don't want to be going and messing with things that could void that warranty. We've inspected the brake ring, we've inspected the brake actuators. We're happy with what we've seen. Now it's time to do the test run. So we'll take the machine up to about 30% speed, do the shutdown, and just watch the brakes apply. And from there we can capture some data and work out if our changes have made any difference. Okay, let's hit the start.
Away we go.
No, it's all good. It's just that when it goes in, you just got to have it in that right position, otherwise it gets a little bit snagged on it. It's all good.
In Newcastle, 2 teams from Port Waratah Coal Services are halfway through a 3-day job to replace a spout and trimmer flap on this massive shiploader. They've just secured hooks and chains in order to hoist the new 3.5-ton chute into place.
Yep. Yep. You're our eyes, Darren.
Right, mate, here we go. Slow and steady.
Coming up pretty level. I reckon we'll just come straight up. I reckon it'll be cool as. I think everyone was freaking out. What muscles we doing here, mate? Triceps.
They better keep working those muscles because the new trimmer flap has just arrived.
That's easier now. We must be doing it even.
Can you be my eyes, mate, and get down there and just see when we're all going to come up? Right, the 4 of us now. I reckon we get it to around about 6 inches away from the face, and then we can install that thread bar then so we get the right hole so it's going in its right position.
Yeah, Dodsy, stop.
Yeah, whatever you're doing there, you're spinning the chute round, and I've got to have it going the other way to line the hole up. That's good. That's coming round nice. Hold it there.
Stop, stop. Stop, stop. You might have to come back off a bit. Back off. Yeah, back off. Yeah, a little bit. Yeah, righto. We might have an issue. Take him back down.
Centimetres from their goal, Wayne has spotted a problem. A big problem.
I just wanted to see if there was a lip in there and see what the old one was, because I don't think that's going to fit up in there.
Let's go have a look.
So that locates inside of there. So we've got tiles all the way to there, and it's all like flush all the way out there. So we've got a design issue.
This design issue could blow their 3-day schedule out of the water.
Probably looking at
6 stands, so 2 under the chassis at the front, 2 under the front axle, 2 under the hoist cylinder mountings.
The Hastings Deering team are performing a delicate balancing act on this massive brand new Cat 794 mining truck as they race to assemble the main components by the end of the day. The pressure's on, with the truck's new owners there to watch the assembly process.
The operators, they enjoy these trucks. Just the technology, the ride in the truck, the feedback I'm getting from our people is really good. It's a bit of a fun day for the team as well. Monday fun day, coming to Hastings Deering, just looking.
Fun to watch, tough to achieve.
There's a few headaches along the way, making sure the pins line up right. They don't line up, and you've got to try and move a little bit with a crane, and they move a little bit too much. Generally battle with the wind if the wind tries to push the truck around.
The current challenge, getting support stands in place.
High risk category of work. Basically, if something goes wrong, it can be catastrophic. So all the guys, you know, they're well trained and know what they need to do, and basically everyone wants to go home at the end of the day, so we do it safely and correctly, and all is good.
There's a special little dolly trolley to help install the stands underneath the truck, once again keeping the guys out of line of fire, obviously while the chassis is under the crane.
Again, only essential crew are permitted in the assembly zone.
The chassis is up on stands now. Resetting for the next lift now, which is the superstructure, like the cab platform.
Dual lifts are challenging, requiring skill and experience from both operators to succeed. Dealing with the wind is one issue. Another is performing a perilous mid-air turn with 14.5 tonnes of precious cargo.
Maybe we should start looking at what the hydraulic operating pressure is. Maybe that's a bit high.
On the snowy mountains at Guthiga Power Station, a brand new generator unit has the shakes. The team have changed some operating codes, hoping their high-tech remedy will solve damaging shutters in the turbine's braking system.
So we've seen the brakes come on.
Takes a fair while to slow up this big rotor, doesn't it?
Well, it's 110 tonnes of rotating mass, coupled to a 45 megawatt generator. It's a big machine. Sounds pretty smooth at the moment. We should go and have a look at the vibration monitor data and see if we're picking up the brake vibration on that.
That run that we just did, we can see there's no spike there. So I think those code changes seem to have done a bit of a job of minimising our vibrations.
Yeah, that's
pretty
great
good to see.
Today's test was definitely a success. It's just It's great to have the bells and whistles on the machine that can give you that information so you can make confident decisions and know that the changes that we made today are the right changes for the problem, and we can move forward. We can get this machine back in service and keep generating power.
But there's another mega machine to get back up to speed. And it's got to happen before the evening demand for power hits its peak. The tools are ringing out in Unit 2's turbine as the crew slog away, getting 24 vital snap links back into place.
It's a fairly small turbine compared to most of them in Snowy Hydro, and it is fairly tight, confined area, a few little pinch points in there.
It's tight, all right, there you go.
That's the last one, isn't it?
This turbine is back in business, which means Guthaga Power Station is now able to run at full capacity again, using its mountain fresh water supply to pump out plenty of power that'll keep thousands of households bright and warm.
So we've got a design issue.
So what we've got on the new one, we've got tiles all the way to this lip here, so therefore it won't actually slot inside of it.
A design flaw in a new component has brought work to a standstill on a wharf at Kooragang Coal Terminal in Newcastle.
Everything else was trial fitted, but the whole spout itself obviously can't be trial fitted to the machine. This is its first fit.
To make it fit and keep this project on track, a scaffold's been erected so the problematic tiles can be jackhammered away from the rim.
It's obviously put us back, I'd say half a shift. We should be able to have enough clearance to pick that chute up, fit up to the slew bearing. This ship loader's got to go back online Friday night, back to operation, so it's all about what can we do in that time frame. The one, get the best result. Two, it's going to leave this machine in a safe integrity.
It's the final day of the job. The overnight team has worked some mechanical magic rectifying the design flaw on the spout. It's now in place, ready for the trimmer flap to be attached.
She's all bolted, torqued up to 279 Newton meters, had a really good run.
Probably the only issue is this new trimmer flap. I haven't seen it, hasn't been in before, so just like the chute, there might be a few unknowns, but it's pretty much basic mechanical principles, just like the old one when it come off. We'll give it a crack and see how we go.
You're pretty close, just keep it tight to you. Yep. Righto, where it looks...
Cue the cherry pickers. It's a team effort to get the bolt holes lined up.
Go seaward, and now come down, touch down, hold him there. And a spherical bearing in the centre, so the inner race can actually move. So we've got kind of trying to line three surfaces up at once.
A simple hand tool could make all the difference.
We're in.
Beautiful. We had the guru on the other side. I think I owe him a carton of beer now. All went pretty good. That episode with the spout not fitting, but you know, you get those sometimes. But other than that, that's part of life, being a fitter, really. You've got to come across those things and you deal with them when you get them, and that's kind of part of the interesting stuff that we do, you know. That's why we like doing what we do. If everything was easy, maybe it'd be a bit too boring. So we have our big weeks and our cruisier weeks, if you will, and this one was a bigger one, so it was good fun.
Next, we'll put the superstructure up, and then it'll be a rear axle housing, and it'll up on stands at the back as well. So, and that'll be it, ready for hosing and wiring.
In Mackay, A pair of crane operators are pulling some intricate moves at the Hastings steering assembly pad, swinging the cabin of a new truck into position.
It's not their first rodeo. They've done many of these lifts for us.
It takes a bird's eye view to help land this bulky load accurately.
Just aligning the superstructure on the locating pins. There's special locating blocks, so it's square to the machine, because after this is assembled, there's a lot of other components like the stairway, access system, everything else that's got to be bolted on. So it's imperative that we get everything squared up and installed correctly.
Just placing the end caps on, making sure it's not going to go anywhere. Not like it will, but you know, pretty much just getting up there nice and tight so it doesn't move. Two-man job, one to hold, one to place the bolts in and rattle them up.
And now for the grand finale.
For the last lift of the day, we're about to install the rear axle. Crane's all ready set to lift it up. We're installing the front banjo pin to start with, followed by the rear dog bone pin.
That's almost 20 tonne airborne. Now for the banjo pin. And finally, it's home.
Went well. A little bit of hiccup there putting that pin in, but after a bit of a readjustment, it went in.
Is our final assembly for today.
Good feeling that the big bits are all done.
Came down to the crew that I've got. The guys have done this many times, so they work well together. The crane company, they've done this many times as well, and as I've said from the very start, good communication between all.